This question is based on meter bridge. So there is a meter bridge. Let's consider this is the meter bridge. Here we will have two sides, where one side we can connect known resistance. Let's consider this is the known resistance R, and on the other side we can connect unknown resistance X. And this is the meter wire. A and B is the wire which has length 1 meter. So from the middle of these two resistors, we can connect a galvanometer and a jacky. So if you place the jacky on this wire, of course there will be a power supply. So if you place the wire on this, sorry, if you place the jacky on this wire, at some point the galvanometer will show zero deflection. So that point is known as balancing point. The the distance between starting of this wire, say for A, to that particular point is known as balancing length L. Since this is 1 meter, if you want to write the remaining length in terms of centimeter, it's going to become 100 minus L. Okay. Now, in our case, they are telling R equal to 2 ohm. The left side resistor is having a value 2 ohm. This X we don't know, and balancing length is 40 centimeter. So using this, we should find what is this X. This is the first part of the question. So that we can do with the help of Wheatstone bridge. So meter bridge is an application of Wheatstone bridge. This is how the Wheatstone bridge will look like. So there will be a resistor in the middle also. Instead of that, I will put a galvanometer because there will be some battery. Let me name it ABCD. Okay. Now, when this resistors A, B, C, D are in a proper value or proper proportion, then there won't be any current passing through this galvanometer. So that is the case in which we can say that the Stone bridge is balanced. The condition is that A by B should be equal to C by D. So the ratio of resistance A and B should be equal to the ratio of resistance C and D. Then there won't be any current flowing through this galvanometer. Here it's quite similar to the same thing, where instead of A we have R, instead of B we have X. You can ask where is C and D? C and D is given by this wire, portion of wire. So the length of the wire L offers certain resistance that we can consider as C. Similarly, this 100 minus L offers other resistor or resistance. Now, how to write the resistance of a wire? That we can write using this expression, R equal to rho L by A. Okay. So using all these things, we can find this X. As I said, instead of A, we have R, X, C and D we have to write. That we can write in terms of length itself. Because you see this rho and A is common for both the C and D. Only parameter which is changing is length. Other things are common. So it is directly proportional. So we can take only length. L by 100 minus L. Now let's substitute everything and we'll find the X. So 2 by X equal to 40 by 100 minus 40, that is. So X will become 3 ohm. Now first part of the question is kind of done. Now look at the second part. On shunting the unknown resistance with 2 ohm, the balancing length changes. See, we need to find how much the balancing length is going to change if we shunt this unknown resistance with another 2 ohm resistance. So when we shunt this X with 2 ohm, then the balancing length will change. Okay, let's find what is the balancing length. Then we'll find the change. Let me redraw this again. This time the meter bridge is something like this. Jackie. Here we have X. and here we have 2. This is 2. Okay, and this x is 3. So instead of this 3 and 2 which are in parallel, we can draw it as a single resistance using this expression. When the resistors are in parallel, we just need to take the reciprocal and add. So if we find total, it will become 1.2. So now again we can simplify this one. This is 2. This is 1.2. Here we have galvanometer in Jackie point A and B. Okay, so in this case, let's consider the new balancing length as L dash. This will become 100 minus L dash. Again, let's apply the same condition. A by B equal to C by D. Here, instead of A, B is 1.2, C is L dash, D is 100 minus L. Let's find what is L dash, our new balancing length. So 2 into 100 minus L dash equal to 1.2 L dash. 200 minus 2 L dash equal to 1.2 L dash. So 3.2 L dash equal to 200. L dash equal to 200 by 3.2, which is equal to 62.5 centimeter. So our new balancing length is 62.5 centimeter. Our old balancing length was 40 centimeter. It was given in the question itself. The initial balancing length was 40 centimeter. How much the balancing length should change? So change in balancing length, which is L dash minus L. So 62.5 minus 40, which is 22.5 centimeter. So the last part of the question you have to read it carefully. They are not asking what is the new balancing length, but they are asking how much it is changing. So the change is 22.5. If you don't read the question properly, then you may end up with selecting 62.5, which is incorrect.